In this video, I will start chapter 4. The first section is first derivative test. The first topic of the first section is finding critical values. So what are the critical values? They are the values of f prime that makes f prime 0 or undefined. So whenever the value makes derivative 0 or undefined is a critical value. So graphically, we can say when we have a cusp, for example, vertical tangent, let's say a corner, we have an undefined derivative, right? The function is not differentiable at that point. So function's derivative at this point is undefined. So this is one of the situations that we have a critical value. We have um, undefined derivative. So another situation, we have a horizontal tangent line at this point. So horizontal tangent line means slope of this tangent line being 0. Slope being 0 means derivative being 0. So this is the situation where derivative is 0. This is the situation where derivative is undefined. So graphically, these are the situations where we have critical value. So algebraically, how do we find critical values? Let's take a look at some examples. Exercise 11. Find critical values of this function. So before I take derivative, I want to simplify this function first. Otherwise, I have to apply product rule. I don't want that. I just want to rewrite the function. So let's distribute x squared. It becomes x cubed minus 3x squared. That's my function. Now I'm going to take its derivative. F prime of x equals 3x squared minus 6x, right? So the first situation, f prime being 0. Equalize it to 0. So find the values that makes derivative 0. 3x is common, take it out. X remains here. From the second term, 2 remains, equals 0. So x is equal to 0 or x is equal to 2. So those are our critical values if they make the function defined. So it is not enough to find the values that make f prime 0 or undefined. It's also necessary to make sure that function is defined at that point. If function is defined at that point, having 0 or undefined derivative will give the critical value. Otherwise, it's not a critical value. So let's check if the function is defined at these two values, f of 0. Put this back in the original function, 0 defined. F of 2, put this back in the original function, 2 squared, 4. 2 minus 3 minus 1, minus 1 times 4, minus 4. So it's also defined. So at these two values, function is defined. So those two values make the derivative 0. So we can say x equals 0 and x equals 2 are critical values. This is from the first case, f prime being equal to 0. Do we have the second case, f prime being equal to undefined? Is it possible? It is actually not possible because our function is polynomial. Its derivative is also going to be polynomial. So polynomial functions are not undefined. So there is no value that make polynomial function undefined, so no need to check. So only the first condition, we have two critical values. All right, so this is how we solve the questions. We take derivative, equalize it to 0, check if those values make function define. If they do, then these are the critical values. And if we have to check the numbers that make derivative undefined too. Second question, 2024 second attempt ministry question, find critical values. So we have a division here. So we are going to apply quotient rule. So what is f prime? F prime of x equals, take derivative of top, which is 2x, multiplied by bottom, minus top x squared times derivative of bottom, which is 1, all over square of bottom. Let's simplify this. 2x squared 2x minus x squared, which gives you x squared plus 2x over x plus 1 squared. So I got the derivative. Now I'm going to check those two steps, those two cases, f prime being 0 and f prime being undefined. So let's go step by step. Okay, first case, do we have numbers that make derivative 0? Let's see. F prime is equal to 0. So in a rational expression, what makes the rational expression 0? Top makes the rational expression 0. So equalize the numerator to 0. X is common. X plus 2 is 0. Then x is 0 and x is equal to negative 2. So before we decide whether these are critical values or not, we should make sure that these two numbers make the original function defined. So is f of 0 defined? Go back to the original function. When I put 0 back, it makes 0 over 0 plus 1, 0. So no problem, it's defined. What about negative 2? F of negative 2. Negative 2 squared 4. 4 divided by negative 1, negative 4. So function is defined at negative 2 as well. So we can say these two numbers are x equals 0 and x equals negative 2 are critical values. So we got two values from the first case. What about the second case? Do we have the second case? Do we have numbers that make derivative undefined? Let's check. Do we have any value that make derivative undefined? In a fractional expression, how do you check the values that make derivative undefined? We check the denominator. If denominator is 0, the function is undefined, right? It's fraction. In a fraction, if denominator is 0, it is undefined. So you equalize denominator to 0, which is x plus 1 squared. If this is equal to 0, x is equal to negative 1. So second step would be checking if the original function is defined at that point. F of minus 1 is equal to, the original function is, let me see one more time, x squared over x plus 1. X squared over x plus 1, which gives you 1 over 0. So undefined. Even though we got a number that makes the derivative undefined, the same number also makes the original function undefined. So according to the definition, in order for us to have a critical value, the function must be defined at the given value. Otherwise, it's not considered to be a critical value. So here, negative 1 is not a critical value. It makes the function undefined at the same time. So we just say x equals negative 1 is not critical value. So just two values are critical. All right. One last question about finding critical values. 2024 first attempt mystery question. Let's find critical values. Okay, x multiplied by a to the 2x. We have the same type of questions, same type of mystery questions came in identifying the increasing or decreasing regions too. So to find critical values, we take derivative first. What is f prime? F prime of x is derivative of first. There is a product here. The first one is x. Second one is e to the 2x. Derivative of first is 1. multiplied by second, e to the 2x, plus first x multiplied by derivative of second. Derivative of exponentials is derivative of the exponent multiplied by itself. So it is e to the 2x plus x, 2x, e to the 2x. Okay, that's the derivative. Now we have two cases. Do we have the second case? Do we have the number that make the derivative undefined? No, that there's nothing that make derivative undefined, so we'll just check the first case. Equalize the derivative to 0. When f prime of x is equal to 0, e to the 2x plus 2x e to the 2x is equal to 0. I see a common factor which is e to the 2x, take it out. 1 remains from the first term, 2x remains from the second term. E to the 2x is never 0. There's nothing that makes this exponential function 0. So we just equalize the second factor to 0. 1 plus 2x is equal to 0. Then x is equal to negative 1 over 2. So does that make function defined? F of negative 1 over 2 is, yes, it is defined. There's nothing that makes this function undefined. So we can say x equals negative 1 over 2 is critical value. Option B.